Okay, we're going to differentiate with respect to x these two functions to start off with. Now remember, the rule for differentiation is you times by the power, then take one off the power. So if we have 3x squared times by the power, we get 3 times 2 gives us 6x. Now we're going to take one off the power, so that's going to be x to the 1, which is simply just 6x. Here, with 8 over x, before we can use our rule, times by the power, take one off the power, we need to rewrite it, so as we have got it in power form. Now this is effectively 8 over x to the 1. Now there is a rule for this. When we bring this up to x as a power, then we write this as a minus power. So this is the same as 8x to the minus 1. Easier to think of it as when you've got x to the minus power, you put that on the bottom of the fraction. It means reciprocate it. The minus means reciprocate whatever power you got here. So we have 8x to the minus 1, and we now want to differentiate. So we times by the power, which is minus 1. So we're going to get minus 1 times by 8 is minus 8. And then we're going to take 1 off the power. We'll take 1 off minus 1 and we get minus 2. And that is our answer. So here are two answers to this. Now that was question 1. Let's have a look at question 2. We've got y equals x squared minus 4x plus 1. So if we differentiate this, as the first thing, dy by dx means differentiate. If we want to differentiate this, we times by the power, so we times by 2. Take 1 off the power, just leaves us x to the 1, which is just x. Here, we've effectively got x to the 1, so times by the power we get minus 4, and therefore if you take 1 off the power, this will become x to the 0, and anything to the power of 0 just equals 1. So you get 4 times 1, so it just leaves you minus 4. Now this number here is just a constant, doesn't affect gradient, and that's what differentiation is all about. It's finding the gradient function. As this does not affect the gradient, just moves the whole curve up 1, it doesn't have any bearing in the gradient function, so it just disappears. Now we're going to find the coordinates of the turning point. Now we know that a quadratic of this shape has a U shape. Okay, and a turning point, if you notice here, the gradient is negative and the gradient here is positive. So the turning point is where the gradient switches from negative to positive, and therefore the graph is momentarily flat. So the gradient at this point must equal 0. So we want to find out when dy by dx equals 0 to find the turning point. So 0 equals 2x minus 4. Therefore 4 equals 2x, and we can see that 2 is what x is equal to at our turning point. To find our y value, let's put x equals 2 back in. Let's give ourselves a bit more space to do this working. So y will equal 2 squared minus 4 times 2 plus 1. 4 minus 8 is minus 4 plus 1 is minus 3. So the coordinates of our turning point are going to be 2, minus 3. Now we need to state whether within reason, whether it's a maximum or a minimum. Well, if you look at the graph I've already drawn back here, we can see that it gives us a minimum point on our graph. And the reason why I knew that it was a U shape is because of this. The x squared bit of the graph was positive, so therefore we have a minimum. So this is a minimum. As we have a U-shaped graph. Now we could actually look at the second differential, differentiate this again and see what that gives us. If we find the second differential, we call that d2y by dx squared. So you differentiate the expression again, and we're differentiating 2x minus 4 now, because that's what dy by dx was. Differentiate again, so 2, that's x to the 1, so times 1 times 2 gives us 2. That becomes x to the 0. and x is 0 equals 1. So therefore we just get 2 times 1, which is 2. The minus 4, remember what we said about constants? Any number doesn't affect the gradient, so that just disappears. So second differential equals 2. Now if the second differential at this point is positive, then you get a minimum. And if it was negative, you would have a maximum. Seems counterintuitive, but that's how it works. Now to just recap everything we did in this question, originally we differentiated this. Remember, you times by the power, take 1 off the power to get your differentials. So that's our first differential there, and simplified. Again, if you've got a fraction, remember when you bring it up, the power becomes negative. So x to the 1 becomes x to the minus 1. And then you can use your same rule for differentiating here of times by the power and take 1 off the power. On each stage, we just follow the rule, times by the power, take 1 off the power for each section of the differential. So we did it for the x squared to get 2x, we did it for 4x to the 1 to get minus 4, and the number we realized just disappears. We found turning points. Okay, a turning point is where you have a minimum, a local minimum, or, actually I didn't show, but you could have a local maximum. So you're going from positive to negative is also a turning point. Okay, this is what we call a local max. So this is what a max looks like, and this is what a min looks like. Okay, so those are your two turning points, and always d2 dy by dx equals 0 at these points, and that's what you put in. So you change the dy by dx here for 0, and then solve that to find x, then put the x back in to find y. And we want to find a reason for y, to say whether it's a min or max. Well, with x squared graphs, we know that positive x squared, so if you have x squared term as positive, then you get a U-shaped graph, and if you have a minus x squared term, we get an N-shaped graph because the x squared dominates the graph. So therefore we can see here that we've got a positive x squared, so you get a U-shaped graph. Alternatively, you can find the second differential. In this case, if you differentiate the expression again, you will get a positive value. Alright? If this was a function of x, we haven't got any x's in here, you put the x value in to find out whether it's positive or negative at that point. Okay, so it's positive, therefore we have a min. If it was negative, you get a max. Alright, it's important to know that that is the case.